अस्सलामुअलैकुम। बच्चों के लिए वीडियोस के ज़रिए तालीम और तरबियत का सिलसिला शुरू किया जा रहा है। चलें बच्चों, आज देखते हैं कि आज की वीडियो में हमें क्या मैसेज मिलता है। जज़ाकल्लाह।
Now a very age-old experiment I am going to do. Probably you know this experiment, that I have filled up a glass completely. Okay. Now, instead of a paper card, in the book it is written that you need a paper card. I take a plastic card, because I cannot change the paper every time. So, I put the plastic card on the top of it. Then what I am going to do? I hold it, then what I will do? Good. So, I am going to turn it over, and if I remove my hand, then what will happen? Will the water fall?
No.
The water will not fall. This experiment in the book says that it demonstrates the property of the upward force due to atmospheric pressure. Whatever is the force due to this water, weight of the water, the atmospheric pressure is acting from below. So, because of this area, the force acting here is the area into the atmospheric pressure. So, this force is balanced by this, that is why it is not falling. So, this is a very common experiment that it does not fall. Should I turn it over, will it fall? If I gradually turn it over, is it falling?
No.
See?
Yeah.
Okay. Now, I just a little bit of water I decrease, some water I am decreasing. Now, you have to tell me what is the pressure inside. When it is open, what is the pressure inside? This air.
The same as the atmosphere.
Same as the atmospheric
Same
pressure.
as
You agree?
Yeah.
Okay. So, this is same as atmospheric pressure. So, I close it. Now, if I turn it over, then you see, if I turn it over, the atmospheric pressure is acting,
Yes.
and here, what is the pressure here?
It is reduced.
It is reduced. How do you know? Why it is should reduce? Very good. She said reduced.
Yeah.
This is really unusual. Normally, even the college students, they say that it is atmospheric pressure. How do you know it is reduced? Why it should reduce?
The water is less, so the weight of the water is minus.
You see, if it is atmospheric pressure and if this water is here, the atmospheric pressure is having some force because of this area. This is also having a force. So, on this plate from the below, atmospheric pressure should cancel this one. It is upward, this is downward, and the water is also acting downward. Then should it remain there or fall down? Huh?
It will fall.
It will fall.
Yeah.
No. But you said that pressure is less. I don't know how you say, probably you have seen it somewhere, isn't it? Yeah, okay, does not matter. She has seen it, but she has to understand why it should be less. Now, I release it, it is not falling. Now, here is a nice observation you have to make. That means, there is a force due to atmospheric pressure here.
It is
Hai na?
equal, means both forces are equal.
Both forces are equal. Very good. She is wonderful, because she is saying that the upward force and downward force is equal. Normally, people doesn't say. This is a good observation. That means, when something is not falling, the downward force and upward force, they must be equal. Otherwise, they cannot balance. But we have to see why they are balanced. Why they are balanced? What happens? For that, I have some heavy coaster. This is coaster. Okay. This is quite heavy. Okay. I put it here. Now, you see when I turn it over, see the coaster is really moving,
Yeah.
and if you see it carefully, can you see a layer of water can be seen
Yeah, around it.
around it? So, something has happened. It is not like when I was holding it, there is no gap. Now, I turn it over and you see this coaster is moving this way, that way, it is moving. So, we have to prove it. What has happened? Otherwise, there is no meaning. If I say the pressure is lowered, that is why it is balanced, that is not an experiment. In an experiment, you have to prove it. And fortunately, one of the 11th class students suggested, this is a very special glass.
Yes.
You see, with a hole at the bottom. If I close the hole, what will happen?
The water will not fall.
It is just like this glass.
Yes, same like.
Now, I am closing it with this. Now, I turn it over, release my hand, this happens. Experiment always fails. So, you have to be very careful when doing the experiment, whether the hole is completely closed or not. Several things you have to see, carefully you have to hold it, and that is why I have taken this thing. Then carefully I have to see, and it is not falling.
Yes.
But the coaster is still moving. Can you see?
Yes.
Now, if I release my finger from the hole, what will happen?
Water will fall.
That shows that the pressure inside must have less.
Less.
So, when I open this, some air goes inside, make the pressure equal, because the hole, through the hole the air pressure is acting. So, because of the weight of the water, it fall down. So, any experiment you have to do in such a way that you understand. But this is not enough. You see, with this card and water, so much water is there.
Yes.
If I do not take any water, why it is sticking?
Because the pressure inside the glass is equal to the pressure of the outside, which is acting outside.
But what about the weight of this? What about the weight of this? This is heavier. Okay. It has some weight. If the air pressure is equal to this, that means force inside and outside is equal, because of the weight it should fall. And see the sound, see the sound. Why the sound has come? Because at least something is holding it.
Yes.
That we shall discuss later on, just little bit later. Now, if the level of water can be anywhere, is it that the forces are always equal? It can be,
Yes, it can be.
because the weight of the water is changing. So, as she said that when the force upward and force downward are equal, then only it will stay. But when this much water is there, force is different. This much water is there, weight is different.
Yes.
When this much water is there, weight is different. So, every time the weight is different. So, is it that it is continuously changing? Let us see. So, what I do, I take a modified thing. This is my modified material. I place it on this, then it turn it over, and the entire thing is suspended here. Now, can you see I have some coins? Each of these coins actually 5 gram weight. Now, I am putting the coin inside. Is it falling down?
No.
One more, each is 5 gram. Is it falling down?
No.
put more 3, 4, 5, 6, 7. That means force is increasing. So, it must have changing its condition, otherwise it cannot balance. So, we have learned that when different amount of water is there, then the force is also adjusted. This is called self adjusting force. Though this is a very simple experiment, people are doing from a long time, but I have modified it to show that when the water levels are different, then it has happened. But one thing I want to add, when I have put this only, which force is holding it? Now, I am going to do that experiment. In the next half, I am going to do. Okay. Thank you very much. Thank you.
You can help a child learn about weather by making rain in a jar. You will need a glass jar, a plate, water, and ice. Heat the water until it's steaming. Pour it into the jar and place the plate on top. After waiting a few seconds, the child can put the ice on the plate. Then they can watch what happens. You can explain that water went up into the warm air, and when it hit the cool plate, it formed into water drops that came back down. Then you can say, this is how rain is made. Water in the air forms clouds, then comes back down as raindrops. This activity helps the child understand where rain comes from.
In this video, you'll learn to make a wonderful water fountain with very simple materials. For this, you will need a balloon, a plastic bottle, a bendable straw, glue, and a pair of scissors. Make a hole near the mouth of the plastic bottle with scissors. Insert a straw in the bottle and secure the hole with help of glue. Fill the bottle with water. Now blow a balloon and hold the neck with fingertips. Carefully fix the balloon on the mouth of the bottle. When you release the air from the balloon, it creates pressure in the bottle and thus pushes water out, creating a wonderful water fountain. So, let's look at what actually happens in this experiment. The air inside the balloon is under higher pressure. When you place the inflated balloon on the mouth of the bottle, the air pressure on the top of the bottle increases. This pushes down on the water in the bottle, which rises through the straw and comes out, making a little fountain. Instead of a single straw, you can also fix 5 straws in the bottle. You can fill the water in the bottle and fixed an inflated balloon. You'll see an elegant fountain with 5 streams. Make your own pressure fountain and have fun. We hope you enjoyed this experiment and learned something new today. For more such hands-on science and mathematics activities, visit our YouTube channel, IISER Pune Science Activity Center. Thank you.
जी बच्चों, उम्मीद है आपको ये वीडियो पसंद आई होगी और इससे बेहतरीन मैसेज भी मिला होगा। अगर ऐसा है तो कमेंट्स में लिख कर हमें बताएं और हमारे चैनल को लाइक करें, शेयर करें, सब्सक्राइब करें और बेल आइकन को प्रेस करें ताकि इसी तरह की वीडियो आपको मिलती रहें। जज़ाकल्लाह।